Okay, hi everyone. Today I have the honor of introducing our distinguished guest speaker, Dr. Conklin. Dr. Conklin obtained her PhD in linguistics and cognitive science from the University at Buffalo and currently holds a position as full professor at the University of Nottingham. Dr. Conklin is largely interested in how the mind represents and processes first and second languages. As such, her research focuses on the learning and processing of multi-word units in both first and second language, implicit and explicit word learning, and automatic word activation in a speaker's first and second language. During her incredible career, Dr. Conklin has also fostered relationships across disciplines and with academic faculty in other fields. In these interdisciplinary endeavors, she employs psycholinguistic research techniques to answer real-world questions pertaining to the readability of language in various contexts and populations, such as legal contexts. Dr. Conklin has also published her work in various peer-reviewed and top-tier journals, such as Language Learning, International Journal of Bilingualism, Language and Speech, and Second Language Research, among others. Today, Dr. Conklin will discuss with us ways to use eye tracking to study processing and acquisition of formulaic language. So please join me in welcoming Dr. Conklin.
Hi, everyone. It's really nice to be here virtually. Yeah, and thank you for that really nice introduction. So whenever I say I'm from the University of Nottingham, my accent gives me away. So the introduction saying that I was at the University of Buffalo indicates that I'm not actually British. But I've been in the UK now for about 16 years. Somehow the accent hasn't quite rubbed off on me yet, though. Maybe in 16 more years. So thanks for having me here today. It's a real pleasure to be here. So as you said, I'm going to talk about eye tracking and applying them to formulaic language. And I don't know how the format really usually works, but please, if you have questions as I'm going through, if I'm talking about stuff, I appreciate questions as we go through instead of waiting till the end. So if there are things you want to discuss or things you want to pick up, I really appreciate if you just shout, or I don't know if I can see you raise your hand. You might have to jump up from your desk so I see you if you have questions. All right, so basically I'm just going to provide a bit of an overview to formulaic language, how I see it, what it encompasses. Then I'm going to talk a little bit about eye tracking and some things you might want to think about if you're eye tracking formulaic language. I'm going to give you very little bit of background to the two studies, the main studies I'm going to talk about today, so the papers that you read, and then we'll turn to those, and then some kind of broad conclusions that hopefully we can come to. So formulaic language. So we've got our bread and butter here, or is it butter and bread? When I think about formulaic language, so I work a lot on vocabulary learning, and I conceive of formulaic language being a part of vocabulary learning. So I take this example of my niece who's growing up outside of Chicago in a monolingual English-speaking house. And so as she grows up, she hears a bunch of words and phrases in her environment. So mommy, daddy, but also mommy and daddy, cookie and milk, but also milk and cookies. So she had the fortune of actually being selected to go to, even though she's monolingual, to go to a bilingual school. So half of her day is in Spanish and half of her day is in English. So in addition to all these words and phrases in English that she encounters, she's also encountering them in Spanish as well. So she's becoming hopefully a bilingual child. And you've had other people talk to you and are going to have people talk to you this semester about vocabulary. So I'm going to focus on these phrases like mommy and daddy, milk and cookies. I'm not going to subject you to my horrible Spanish pronunciation, but you can see some examples of that on the screen. So formulaic language. So these things I just called phrases. So is it make a picture or is it take a picture? So for native English speakers, it's pretty clear for us that we take a picture. So is it strong coffee or intense coffee? We could say either thing, but in English, it happens to be strong coffee. Is it salt and pepper or is it pepper and salt? English speakers will have a clear intuition that it should be salt and pepper. And in England, is it fish and chips or chips and fish? Now, you might be excused for thinking that chips are the most important thing and should come first, but actually it's fish and chips. So in British English, it's fish first. So these are all what we call formulaic language. And formulaic language is simply the customary phrasing of a speech community. So there's no rule that I can give you why it's one way or the other, although I have to say linguists have in the past spent lots of time coming up with constraints to explain why one word might come in front of before the other, so why there is a particular order. But there are lots of violations to the constraints they come up with. So a common constraint that they've come up with across different systems is men before women, but then you've got phrases like bride and groom where the woman is first, so that would form an exception, and we have others like ladies and gentlemen that are exceptions to the rule. So even though they've tried to come up with rules to explain why in some of these examples we might have a particular order, or why you might use certain words and phrases, there are tons and tons of exceptions. And what it really comes down to is we can't come up with rules. It's just the customary phrasing of a speech community. So it's just the way we say it. And in psycholinguistics, we say that there are two key features to formulaic language. One, it needs to be frequent, depending on what type of formulaic language we're talking about. What's frequent and what's not might vary, but it has to be frequent. So it has to recur with some regularity in the language. And as we'll see, it has a processing advantage over non-formulaic or novel language. So those are the two things. It has to be recurrent, and it's going to have some processing advantage associated with it because it recurs in language. So is it bread and butter and bread, fish and chips, chips and fish? Is it, could you help me with this, or could you aid me with this? All of these are completely grammatical phrases in English. But in these cases, in the cases that are on the screen, we generally say the former, and the latter is going to sound unnatural to adult native speakers. So we don't say, could you aid me with this? We say, could you help me with this? But both of the options are perfectly grammatical. You could say the latter in any of the cases and you're going to be understood. It's just we just don't say the last example. So it's not the case that when we're producing language that we simply apply syntactic rules to form grammatical utterances. In fact, we tend to produce utterances that are more probable. So all of these are completely grammatical. We could say any of them, but we tend to produce the former examples and not the latter ones. So despite the great potential for novelty that Chomsky has famously discussed, and Pinker and other linguists have talked about, that that one of the powerful things about language is that we can come up with new utterances. In fact, we tend to make use of only a small proportion of possible utterances. So while we could say any of these, we tend to only say the former. So I really like this quote. So just as we are creatures of habit in other aspects of our behavior, so apparently are we in the ways that we use language. So we have these ways that we say certain things or express things, and we keep reusing them. So the question then is, how do speakers learn or acquire this language habit? And one of the questions I'm really interested in is this different in an L1 and an L2, so in a first language and a second language. So some common types of formulaic language. So formulaic language is an umbrella term that encompasses a lot of different phenomena. So idioms are probably the poster child for formulaic language. When we mention, or when I talk about formulaic language, is probably what people think about the most. So our idioms, and these are broadly non-decomposable, so they're not compositional. So I can't tell you the words and you figure out what it means. So if I say shoot the breeze, it's not like someone is taking an arrow or a gun and shooting the air. And there's no way you can take the words shoot, the, and breeze and figure out what it means. Now they're somewhat variable because some idioms are more transparent. So if you take an idiom like add fuel to the fire, you can understand that if you do that, you're going to make something worse. So if someone says they're adding fuel to the fire, you might understand that they're making a situation worse. So they're they're variable in how non-compositional they are, but as a class, you can't simply take the words and add them up and get the meaning straightforwardly in idioms. Collocations, so the example I gave of strong coffee, these are simply word pairs. They sometimes have an intervening determiner or pronoun, and these are simply defined by their co-occurrence. So they occur more frequently than you would expect by chance. So strong and coffee occur more frequently than by chance. If coffee could be combined with other things, you would see things like intense coffee, powerful coffee, and not just strong coffee. So they're co-occurring more than you would expect. And we've got different types of collocations. Another common type of formulaic language are phrasal verbs. And these are a combination of a verb and a particle. So things like look after. Sometimes you can have two particles, so come up with. And the verb and the particle can be separable or inseparable. So turned into, or turned down the job, or turned the job down. So you can separate the particle with intervening words in some cases. Then we've got speech formula, which are just recurring expressions. And these are of variable length. And they're usually used to organize discourse in some way or to convey a speaker's attitude, or things like that. So they serve some sort of communicative function in discourse. So things like, excuse me, you've got to be kidding me, hold on a minute. Lexical bundles, they're kind of like collocations, but collocations are just two words or two words separated by a determiner or pronoun. Lexical bundles are a type of formulaic language that are defined simply by their statistical frequency in a corpus. And we usually do not talk about sequences that are two words long as being lexical as being lexical bundles, then they're collocations usually. So these, we take some sort of corpus, we use a tool like Sketch Engine, and we have it chunk out. It goes through and looks at combinations, and it chunks out sequences of any length, 3, 4, 5, 6, 7, 8 words long that occur with whatever frequency threshold we set for it. So they're defined purely on their frequency of occurrence, and that means they can be complete phrases in and of themselves, or they can be incomplete. So if you take something like a lot of the, usually when we say a lot of the, there's going to be something else like a lot of the time, a lot of the people. So it's not a whole complete syntactic or semantic unit in and of itself, because the tool that we use is blind to anything other than the statistical co-occurrence of the words. Binomials, which is something that I'm going to talk a lot about today, are sequences of X and Y, where X and Y are from the same part of speech. So two nouns, two verbs, two adjectives conjoined by a conjunction, and the conjunction is usually and. Binomials can be literal or figurative. So salt and pepper, fish and chips are completely literal. It's literally salt and the pepper, fish and the chips. But we have something like bread and butter that can be both idiomatic or it can simply be the actual bread and butter. When I talk about binomials, I am excluding any items that are idiomatic. So I'm not talking about idiomatic phrases. I'm just talking about ones that are compositional. So it simply is the two words and their meaning conjoined by a conjunction. So not any idioms in that. And I've done a lot of work on binomials, and you'll hear about that today. So formulaic language encompasses, as you've seen, a broad range of multi-word sequences that fulfill a number of communicative functions, and they vary on a number of linguistic dimensions like frequency, familiarity, compositionality, how literally plausible they are, and transparency. And they differ between the different categories. So idioms, even though they're kind of our poster child for formulaic language, they're some of the least frequent formulaic language. So idioms are, if you take each individual idiom, they're quite rare. Within the category of idioms, of course, we have a frequency spectrum within that. And any of these, they obviously binomials, lexical bundles, they're all going to vary in how frequent they are. But the different classes themselves, some are more frequent than others. And they also vary on their properties. So idioms, one of the ways their defining features is that they're opaque. So you can't simply take the words and figure out what they mean. But even though we say they're opaque, as I said, with the add fuel to the fire example, they vary within the category of how opaque they are. So you'll see that across the board. So we have these features, but even within a category like idioms or binomials or lexical bundles, they're going to vary. So I'm going to talk a lot about binomials today. So these expressions that are two words from the same lexical class conjoined by a conjunction, and I'm leaving out any of them that might be idiomatic. So when I talk about materials, none of them are going to include items like bread and butter that have an idiomatic meaning. So why in the world do I spend so much time studying formulaic language? Well, one of the reasons that I study it is that it's really pervasive. So people have done different studies trying to count up formulaic language, and you see we get counts that are as high as a word once every 5 words is part of a formulaic expression. We see in the Oppenheim 2000 paper that up to 80% of the language was classified as formulaic. And then we get figures that are low as well, around 15 and 20%, but most people are saying around 30–40% of the language we encounter is formulaic. So if you think about our everyday speech, if we're encountering 30–40% formulaic language, it should be a phenomenon that we should study and merits our attention. You might be asking yourself, why do these figures vary so widely? Well, part of it depends on the kind of corpus and the discourse that you're looking at. So written corpora tend to have more formulaic language in it than written corpora, and then different genres, depending on what people are looking at, might vary a bit in how formulaic they are. Also, because formulaic language encompasses such a wide variety of formula, depending on what you count. If you're not counting things like lexical bundles, then your figures are going to be higher or lower, depending on how inclusive and the number of phenomenon that you're actually trying to identify. So if we take all these kind of figures with a bit of a grain of salt, and we understand that they might be counting different things and looking in different contexts, regardless, hopefully this makes it clear that formulaic language is very prevalent in language. So that's why I have dedicated so much time to studying it. All right, so now I'm just going to talk a bit about some concerns or some things that we should think about when we want to do eye tracking of formulaic language. And since you're in this advanced seminar, I'm assuming that you know quite a bit about eye tracking already. So I hope that's true. I'm not seeing any yes or no heads shaking. So no one's jumped up and said no. So I'm just going to look now at 3 types of formulaic language here. So I've got the binomials, so the fish and chips. I've got an idiom, kick the bucket, and I've got 2 collocations, so give up and turn into. And so with Gareth Carroll, who was my PhD student at the time, we really started thinking about, okay, so if we're going to eye track these, what should we be analyzing? What should be our unit of analysis? So what should be our ROI, our region of interest, and what eye tracking measures should we be using? And so if you're interested in formulaic language, this paper might be of interest of you, but so just the kind of things that we were thinking about. So should every word be a unit of analysis? And a lot of eye tracking tools would give us that possibility fairly easily. So it would show us each of these words as a region of analysis. But the problem with this is we can see that a lot of these formulaic units are made up with short words and function words, which are often skipped. So we're going to have a lot of missing data from skipped words. So in most of the experiments that we do, when we do binomials, or I've done a lot of idioms with these 3-word idioms, so things like kick the bucket, where you've got the verb, determiner, noun, people aren't going to fixate on the determiner or the conjunction. And if we take things like give up and turn into, the particle is often going to be skipped. So we're going to have a lot of missing values if we try to start analyzing each word in the sequence individually. So should we just consider the content word? So should we just look at fish, chips, kick, bucket, give, turn? Well, maybe in the first two cases with fish and chips and kick the bucket, maybe we're happy with that. But with these particles, maybe we're not so happy with that. So we have to think about that. Does it make sense to not look at the particles? What are we going to do if we're getting high skipping rates with them? And should we consider the whole phrase? So should we treat the whole phrase as a unit of analysis? So those are the kinds of questions that we need to think about. And so that's just looking at the units per se, but now I'm looking at them as we have manipulated them in some experiments. So I'm interested in comparing fish and chips to a matched item. So in this case is chips and fish. For the collocations, I might compare abject poverty to abject agony and spill the beans to spill the chips. So now if I'm looking at word measures, so I want to compare the processing time in the binomial versus a matched phrase. If I want to compare the word processing times, I need to make sure that the content words that I would like to compare are well matched. So are fish and chips themselves, if I want to compare reading times to them, are they well matched? So I need to make sure that they're matched well on things like length, frequency, concreteness, part of speech, all those things that we need to control. I'm also probably going to want to use a sophisticated analysis, so mixed effects modeling, so where I can put things like first word frequency, third word frequency in my model to account for any differences, because it's probably going to be pretty impossible to control those completely. The nice thing is that fish and chips and chips and chips and fish contain exactly the same words. So in terms of looking at comparing the phrases, they're going to be nice because they're made up of exactly the same words. If we look at the other two cases, so abject poverty and abject agony and spill the beans and spill the chips, the two phrases are different. So I've introduced a new word, so agony and chips. And I need to make sure that everything is matched and controlled. So if I want to look at the whole phrase, are the phrases well matched? And this needs to be in length, word length. So are the words, and the total phrase matched well? What about the frequency of the phrases, the naturalness, maybe the phrases, or the semantic association of the phrases? So some of these have quite strong associations, especially when we talk about things like binomials. Some of the words, so if I say salt, a frequent semantic associate people are going to give is pepper. So is my control item as semantically associated? If not, I'm going to need to account for this. And this might affect both word and phrase reading time. And your research questions and the considerations I've just mentioned are going to impact what ROIs are sensible to consider. And I would say almost everyone, when they're doing research on formulaic language, is going to consider a set of measures on some of the individual words and the whole phrase as well. As the phrase gets longer, so some idioms can be quite long, which is why I've avoided working with them too much. You're going to have to maybe have some other considerations as well. But as you can see, these formulaic sequences are all pretty short. So as I said, we generally look at a range of word and phrase measures. So I'm going to measure reading time to word 1, so fish and chips in the initial spot, and word 3, chips and fish in the final spot. And I'm going to have phrasal measure reading times. Now, obviously, some measures aren't applicable when you're looking at a whole phrase. So we're going to have to consider what measures are appropriate based on the length of what we're looking at. So, and in particular, one thing that we're often interested in formulaic language is skipping. So something that's often unique about formulaic language is when I say fish and, you know, or have a pretty good idea of what's going to come next. You know it's going to be chips, salt, and you know that pepper is probably coming up next. So we might have a high skipping rate for the final word, or which is going to be a problem because then we're going to have a lot of missing data for that final word. So if we're comparing in the third word, I keep pointing at the screen as if you can see where I'm pointing. So if you look at the final word in chips and fish when they're in the final position, we might have a lot more skipping of the chips than the fish because it's more predictable. So then we have to think about how we deal with one of our conditions having more skipping than another. So we often look at skipping both to analyze it, but also we need to think about and how much data we've lost. And then if we compare the reading times for chips and fish, if one of those has a lot more missing data than the other, what's that doing? So we need to consider skipping a lot when we look at formulaic language A, because you might be interested in analyzing it because I have a prediction. If you know what's coming up, you're likely to skip it. And so I want to look if that's true, but also we need to think about it in terms of we might have one of these items that has a lot more skipped data. And so what's contributing to the mean is different than we get less of a contribution of reading times to the mean than in the other condition. So something that we need to be aware of and keep in mind when we're looking at the data. Some other work that we've done, so I've talked about formulaic language and I've highlighted that we've got different types of formulaic language. But one of the things when we talk about formulaic language, so people usually study binomials, or they do a study on idioms, or they do a study on collocations. We have a set of measures that we look at. We have a set of variables that we look at. But where different variables and things that we're interested might be of relevance could be very different for the different types of formulaic language. So again, with Gareth, who was my PhD student at the time, we wanted to compare different types of formulaic language. And so we looked at some variables that we know are important to different types of formulaic language. So we looked at the phrasal frequency, and we looked at this using a zip score, which is a like a Likert sort of scale of frequency from 1 to 7. So you get a zip value based on frequency. We looked at close probability, and these were all assessed. So the close probability was assessed with an offline task with a different set of participants. So we got the close probability for the items we were looking at. And this was idioms, binomials, and collocations. And then for idioms, we also had ratings of familiarity. For binomials, we looked at semantic association because the two words in the binomials can often be highly associated. But if we reverse it, so if I take fish and see how well it predicts chips, it will be different than how well chips predicts fish. So we looked at semantic association of the words. And we did that for binomials as well as collocations. And then something else that has been said to be important in collocations is mutual information, which is a formula that calculates how predictable the two words are. So it's been found to play a role in other studies of collocation processing. So we were interested in looking at all of these variables and looking at them in a range of measures. So you can see first pass reading time, the total reading time for the phrase, word skipping rate, for the single word, first pass reading time, and word total reading time. And this is for the final word of the sequences. And so you can see those are the kinds of measures we looked at, and we looked at when we see an influence of the particular variable. And you can see that depending on the type of formulaic language, we see effects in different places in the reading record. And this is, to our knowledge, the only study that's really looked across formulaic language types. And we had, for this, if you're interested, we had different types of control phrases. So we had different kinds of comparisons with the formulaic language and different types of controls that people might use to really see where we might see evidence of a frequency effect, a familiarity effect, or a predictability effect, for example, like close, showing up in the reading record. And you can see from this that there's differences in where even something like frequency, so the phrasal frequency might show up depending on the kind of formulaic language that you're looking at. So something to keep in mind is that we shouldn't treat formulaic language as if every type of it is the same, and we might see effects showing up in different places in the reading record. So, and this is just an initial sort of examination of this. Definitely more research needs to be done looking into the different types of formulaic language and looking at where we might see effects of different variables that we think influence processing showing up in the eye tracking reading record. Any questions before I move on to the next part? Was that hand? Yeah?
No, I was just saying that we're good. I was trying to give you a thumbs up. You're
Okay.
doing great. Thank you.
Okay, good. You're too far away for me to see other than like a hand in the air. Good. Okay, so now I'm just going to give you a little bit of kind of general background information about formulaic language processing. So one of the things that I said at the very beginning is that in psycholinguistics, how we characterize or define formulaic language is that A, it needs to be recurrent, and B, that it has a processing advantage. So everyone would agree it's across probably disciplines, so not just in psycholinguistics. So if you ask corpus linguists or linguists, a defining feature of formulaic language is that it has to recur. That's basically what makes it formulaic, is that it has some level of repeated occurrence in the language. But the psycholinguistic aspect is that this recurrence, we believe, just like we believe in frequency effects, is going to lead to some sort of processing advantage. So just like frequent words are processed more quickly than infrequent words, formulaic language, since they're recurring multiple times in language, should have a processing advantage. So I just said that without providing any evidence of that. So that's what I'm going to talk about next. And this study kind of lays the groundwork for the two papers that you read today. And in some ways very similar to the kind of studies that you read today. So this was the earliest study I did with binomials with Anna Cianova, who was my PhD student at the time. And we compared binomials and their reverse form. So salt and pepper, which is how we say the phrase, versus its reversed form, which rarely occurs in language or has very, very few occurrences in a corpus. We put these binomials in sentences. So it was just a sentence, an isolated sentence, and it had the binomial salt and pepper somewhere in the middle of it. Or it had king and queen in a different sentence, or fish and chips. We presented these sentences across counterbalanced lists. So if you saw the sentence with salt and pepper, you did not see pepper and salt. If you saw queen and king, you did not see king and queen. So these were counterbalanced, so that half of the items that you saw were the binomial and half of the items were the reverse forms, but you didn't see both of any of the items. We did this experiment with native speakers and non-native speakers. The non-native speakers came from various L1 backgrounds. And so they had different native languages, and we had some demographic data from them. They were all university students, so they all had an English level to gain admittance at the University of Nottingham. So they were fairly high proficiency participants, and they were enrolled on a regular degree, so they weren't in an English language program. They were all matriculated students. So basically, we tracked the participants' eye movements as they read the sentences. And here I'm just going to show you the log transformed total reading time. On the x-axis across the bottom, what you see to the right-hand side is the highest proficiency participants, which are the native speakers. So they're all down there by the 0.5. Those are the native speakers. And then as we moved leftwards, we have the non-native speakers with decreasing proficiency. So close to the 0.5 are going to be the non-native speakers that are the highest proficiency. And as we go leftwards, they're going to have less proficiency in English. The solid line is the binomial, so that's the fish and chips, the salt and pepper. and the dashed line is the reversed form. So the chips and fish, the queen and king. And on the y-axis, you see the log transform, total reading time. If you're lower on the y-axis, you're faster than if you're higher on the y-axis. So what we see down here with the native speakers, we have a significant difference between fish and chips and fish. So the binomial is significantly faster than its reversed form that is unattested or very infrequent in the BNC. For this study, we looked in the BNC. And then we have the high proficiency learners who are overall slightly slower readers. That's to be expected. But we see that they still have a significant difference between the binomial and the reverse form. But as participants decrease in proficiency, we see that not only do their reading times get slower, but the difference between the binomial and the reverse form disappears, so that it doesn't matter if they read fish and chips or chips and fish, and the reading speed is equivalently fast or slow, you would say. So there's no difference. So we see an important difference between binomials in the natives and non-natives, in the native speakers and the non-native speakers who are highly proficient. So in the formulaic language literature, we see a processing advantage across types of formulaic language. So idioms, collocations, binomials, phrasal verbs, lexical bundles. And this is really just a smattering of references. These are not all from eye tracking. So some of these are response times or self-paced reading tasks. And this is not even an exhaustive list. So we see pretty widespread processing advantages across the different types of formulaic language compared to whatever the control is that they're being compared to. But the formulaic advantage is not always found in an L2. And if I had just tested in this previous experiment the less proficient speakers, I would have concluded that there's no formulaic advantage in the L2. But since we did see it in the highly proficient speakers, we can see that there is a formulaic advantage in the L2, but it only arises if you have high enough proficiency. And based on other research that I've done that's not necessarily all eye tracking, the conclusion that we've come to is if you test high proficiency speakers who've had enough exposure to the language, we do always see a formulaic advantage. Equally, if we test very low proficiency speakers and we know what their input is, so we've given them the input or we know what their input is from making a corpus of their textbooks, we do see that they have a formulaic advantage. But the reason that we're not finding it in studies like the one I just did is because they haven't had enough exposure to English to show it on the kind of items that we present them with. So the formulaic advantage in the L1 is pretty pervasive. In the L2, you don't always see it, but if you account for the input that the L2 speakers have, you're pretty much going to see the formulaic advantage there as well. So we just need to be careful when we talk about the L2 group. We need to know something about their characteristics and something about their input. And if they have had exposure to formulaic language, they show effects fairly similar to native speakers. And if you did read the second paper for today, you'll see that the effect might not be identical, but we see a very similar effect. Okay, so now we're going to get into the two papers that we read for today. So you might have more to say about this part since you've actually read the papers and might have more questions and things you want to discuss. So the first paper, hopefully that you all did read, you didn't have to, I guess, read the second paper, is from Applied Linguistics. And we were looking at the acquisition of new novel formulaic language. So we don't know very much about how people learn conventional linguistic patterns and how quickly a processing advantage for them emerges. So I just showed you that people have a processing advantage, but we don't know how quickly this might emerge. But we do know that people acquire language patterns quite quickly. So kids can acquire a word's meaning after a single exposure, particularly if there's strong contextual support for the word object mapping. So if they see a cookie and they hear the word cookie, they can learn that word meaning pairing fairly quickly. If there's strong contextual support, they only might need to hear it once. Or if there's a helpful grammatical context, they may also be able to learn it with one occurrence. I find this statistic just mind-blowing, that toddlers and children in the school years are acquiring a new word almost every 2 waking hours. So they're very quickly hearing something from the environment, and they're learning it with very little exposure. Adults who attend really horrible, usually introduction to psychology experiments that you have to do for course credit and are have to do language experiments. They're shown in tasks like the one I'm going to talk about. They're shown a novel object, so a weird shape or object that they've never seen before, and they hear a weird word that's a novel word that they've never heard before, and you listen to 40 or 50 of these repeated. So strange object, a whole bunch of new words that you've never heard before. We see that people can learn these or have some knowledge of them in an experimental session. And they're also sensitive to the frequency of occurrence. So if I have this novel object that 80% of the time is referred to by one label and 20% by another label, I pick up on this, that one label for this weird object is more common than the other. And if you think about this, so when I lived in the US, I had this object in my living room. I called it a couch. I was aware that people called it a sofa, not a term that that I would have used to refer to it. As soon as I came to, so I was sensitive to the frequency of occurrence of the two words. When I moved to the UK, I was very aware that I quickly became aware after a short time that sofa was actually the frequent way to refer to it, and couch was something that they were aware of as a term, British speakers, but didn't usually use. So we encounter this kind of thing out in the world. So we might have something, there are different labels for it. We're sensitive to how frequent one label is over the other. In an experimental setting where we hear novel word, see novel objects, we're aware of the difference in percentage of or have some idea of the frequency with which an object is labeled one way versus another. So it seems like we're very attuned to picking up these kinds of patterns for languages. So this is called this, so we can learn objects and labels fairly quickly. So children and adults seem to have a really remarkable ability to extract language regularity. So this thing is called this, and we can do it quickly without lots of input. But the phenomenon that we have been studied, so knowing what objects are called, are really important for meaningful, successful communication. So if a child wants a cookie, they need to know it's called a cookie and not bean. So if they say bean, they're going to get something very different than if they say cookie. Making these kinds of form meaning mappings are really important for successful communication. Now, if we look at this in comparison to formulaic language, especially something like binomials, if I say many countries agree on the importance of the separation of church and state versus many countries agree on the importance of the separation of state and church, you're probably still going to understand what I mean. With the second one, you might think that maybe I've picked up some strange formulation in British English. Maybe British people say state and church instead of church and state. So, or it could mark me out if I say the latter as a non-native speaker. Or you might think I'm, for some reason, trying to place importance on state. So I've sort of promoted it in the phrase. But it doesn't really change what I've said. It's still completely understandable whether I say church and state or state and church. However, if I say bean instead of cookie, that's going to change completely what you think I'm communicating to you. So in some ways, this pattern like binomial, so noun, and that it has a particular order, is much less important for communication. So do people pick up on these kinds of linguistic patterns? And how much input is needed for us to learn these patterns? So as I said, we've seen an advantage for existing formulaic language, but how do we learn this? How does it come about? How quickly do we get this advantage? And particularly in a naturalistic context. So like I was explaining, these experiments that people have to do in first year undergraduate psychology courses, where you see this like 40 or 50 new objects and here 60 new words. That's not a natural context. That's not how we're generally exposed to language. So if we're exposed in a more naturalistic context, how quickly will this processing advantage emerge? So Gareth and I, so again, working with Gareth, we did this study shortly after his PhD. So we wrote these stories. So this picture here will hopefully begin to make more sense. So we wrote stories, for example, about this couple who had just bought this new house. The house was a fixer-upper, and it was going to take a lot of time and money to fix up. So it has the existing sequence, time and money. And one of the problems in it were its wires and pipes. So the wires and pipe were in bad condition. The wires and pipes were going to need to be fixed. So someone came in to look at the wires and pipes. So dispersed throughout the story were occurrences of these new formulaic sequences that Gareth and I made up to go along with we wrote 3 different stories. So they went along with the different story contexts that we wrote. So we weren't sure if this was going to be successful, if people in a natural context could pick up these kind of patterns. So as a first try, we only did this with monolingual native English speakers. So we weren't sure if they were going to be able to do this, if people could just pick this up in the course of reading these sequences in a story. So we wrote 3 stories. They were just around 1,500 words long. They contained 12 existing sequences that were all noun and nouns. These were things like time and money. And somewhere towards the beginning of the story, they occurred once in their forward form, and then later in the story, so more towards the end, they occurred in their reverse form. So this is exactly like the experiment that I told you about with salt and pepper and salt that I did with Anna, where people read sentences. But now it's but the study I did with her, these were just isolated sentences. Here they're within a story, and they're not counterbalanced. So people saw time and money, and they saw money and time, but at different points in the story. Now we should get the same result that we saw in the study with salt and pepper. Hopefully, even though it's in a discourse and not in isolated sentences, hopefully we still see this formulaic advantage that we saw before, and that's widespread in the formulaic literature. If we don't see that, then I would have to be worried. So we put those in. So we wanted to see the formulaic advantage, and it should survive insertion into a larger discourse. But then we invented 25 novel sequences, and they were noun and noun or verb and verb conjoined by and. And so they were things like wires and pipes. And the items occurred between 1 and 5 times. So 5 items occurred 5 times. Another 5 occurred twice, another 5 3 times, another 5 4 times, and the last 5 times. But that means that, so one of the things when you read the paper that we talk about is that all of the items, so all 25 items occur once. So we've got 25 items contributing reading times to the first occurrence. We've got then 20 items occurring contributing reading times to the 2 occurrence, because even if you occurred 4 or 5 times, you also occurred twice, so you're contributing. But when we get to the ones that occurred 5, there's only 5 items that contribute reading times to the 5 occurrences. So we do lose statistical power as we go through the number of occurrences. And one of the reasons that we made this decision, we didn't know when and if it would emerge, so we wanted to look at sort of every point, but we couldn't do more items. Even though we knew we would lose item power, we didn't want to do more because already having an item occur 5 times in these stories was a lot. So we didn't want people to become attuned to the fact that we were looking at binomials. So we thought if we had 10 items at each level, then you would just have so many of these binomials. It'd be very clear what we were studying. So In terms of a methodological choice, we knew that it might be hard to find something at 5 times because we only had 5 items contributing, but at the 4 repetition, we had 10. So we were hoping that we could at least see it there. So however many times an item was slated to occur, so if it was in the one repetition category, then somewhere later in the story, it occurred in its reverse form. So something that occurred 3 times, and then later it occurred in its reverse form. And you saw the forward forms before all of the occurrences of the reversed form. And we controlled these, as you saw in the paper, for lots of different things. We looked at some of these variables in the analysis, as we include some of the variables in the analysis. Also, when we created the items, we worried about and thought a lot about the different characteristics and properties that linguists have looked at in terms of what might mean that one word should go first. So why there might be some phonological constraint or phonological reason that why wires should go before pipes. And so we looked at those and tried to control those as much as possible. But the other thing that we did was we had 2 lists of the story. So if you were reading list 1, you read wires and pipes, wires and pipes, wires and pipes. And for you, the reversed form was pipes and wires. If you were a list 2 person, you read pipes and wires, pipes and wires, pipes and wires. And for you, the reverse form was wires and pipes. And we didn't see any difference across the 2 lists. So in the end, we collapsed the data and analyzed it together. So we, since there were no list differences, it looked like we had done a good job taking care of all of the constraints that linguists said we should worry about. So it didn't seem that our items, based on other constraints like their phonological form, had a preferred order, since there were no difference between the 2 lists. So we controlled a lot of variables, or as many as we could, and some of these are included in the analysis as well. So things like frequency. So people read the story while we monitored their eye movement. So I had a nasty feeling that the wires and pipes in the garage. And later in the sentence they read, I asked if the shop dealt with pipes and wires to see whether, and we were interested in particularly the phrase and in the final word. We also analyzed the first word, but that's much less interesting. We're interested in the final word, but you'll see data presented about the content words as well as the whole phrase. So the first results I want to mention are the existing binomials. So these were time and money versus money and time. So people read time and money once, and later they read money and time, so the existing phrases. And much like we saw in the original study that I mentioned, we get this very nice across the board formulaic advantage. So time and money is faster than money and time. And we see this in first pass reading time and total reading time, and we're seeing it in the words and the phrase as a whole. The big question is, what about for the new ones, so wires and pipes that we made up? So we don't see anything in first pass reading time, and we don't see in first pass reading time in terms of the words or the phrases, but we do see the effect emerging in total reading time for the whole phrase. So wires and pipes, if that's what you read in the forward form, is faster than the reverse form, pipes and wires. Now here we have 2 figures or a figure with 2 panels from the paper. At the top is the first pass reading time that's log transformed, and in the bottom it's total reading time. And in both of these, on the left-hand panel, it just shows you what happens at each occurrence. Now remember, different number of items are contributing, so all 25 contribute to the first occurrence, and then at each one they're decreasing by 5. And what we see is that over the course of reading wires and pipes, you're getting faster. So the last occurrence is significantly faster than the first. And then in the right-hand panel, it's showing the penalty for reversal. So if I've only read it once, there's very little penalty for reversing it. So if I read grass and leaves was another binomial that we made up for this story. Grass and leaves, if it only occurred once, and then if you reverse it, leaves and grass, there's little penalty. And this emerges in total reading time. So what you see in the bottom right-hand panel, we see that the more you read, the steeper the incline in the reading time. So the more times you've seen a new binomial, the slower your reading is. If we just kind of take a cartoon caricature of this, what we see is that reading times for new formulaic language becomes faster as the number of occurrences increases. So those are the red bars. So the more I read them, the faster they get. But the interesting thing is that kind of blue-greeny bar at the end. So if you look at it compared to the red bars, we see that it's not as high as the initial red bar. So pipes and wires, even though I haven't seen pipes and wires before in the story, it's faster than the first time I saw wires and pipes when I first read the story. So it seems like co-occurrence of wires and pipes, so these two words throughout the story, is recorded in memory. And this makes the reversed faster than the initial encounter of these two words. So it seems like these two words are being associated in memory. So wires is being associated to pipes. So when later I read pipes, even though I've never seen pipes first, I have some expectation of wires. But also it's important to note that this blue-green bar is higher than the fourth and fifth red bars. So there is a penalty for pipes and wires, the reverse form, over the forward form that you've seen. So it seems like in 4 to 5 exposures, I'm getting some information about the co-occurrence of these words. So well, wires is associated with pipes. So if I see pipes and then I get wires, wires is somewhat fast. But there is a penalty to it. So I seem to know that it's not the forward, it's not the expected form. So I'm not as fast as I was in the fifth occurrence. So it seems like two things are happening. We're beginning to associate these words in memory, and we have some idea about the order of the two words. So what about in an L2? So we got this in the L1. We were really happy about that. We weren't sure if it would happen in this sort of natural reading context. So we wanted to know what about in an L2. So for this, we had some collaborators. So Suhad and Dina in Saudi Arabia. So Suhad had years previously been a PhD student at the University of Nottingham, and is now working in Saudi. And they recently opened up a new eye tracking lab and wanted to do some eye tracking work. So we thought it would be a great chance to do this wires and pipe study in an L2. So we worked with them to carry out this study. All of the participants have the same L1, so they're all Arabic L1 speakers. There's 39 of them. You can see a bit about their demographics. So they rated their performance, but we also had them do the yes/no online vocabulary test to get an idea of their vocabulary levels. And their mean scores put all of them in the upper intermediate to proficient level. Now, these are all people in Saudi Arabia. So unlike the first study that we did on salt and pepper, where the students were all in the UK and they were highly proficient in English, these students were all these people were all in Saudi Arabia in an Arabic speaking context, but were upper intermediate to proficient in English. And you can see some of them, the range goes up to quite high on the vocabulary test. So some of them are quite high proficiency, but it's quite variable. So we took the stories that we had from the wires and pipes study, but we changed them a bit. So we now increased the number of items. So we had 32 noun and noun binomials, 12 of which were the existing, and 20 were novel. For the novel ones, so the ones we made up, so like the wires and pipes one, they didn't exist in Arabic, with the exception of 2 items that had some frequency in Arabic. Of the existing ones, so ones like time and money, fish and chips, 6 of these existed in Arabic and had the same order. So it would be salt and pepper in English and salt and pepper in Arabic. Of the other existing ones from the study, the other 6 actually had the opposite order in Arabic. So if it was king and queen in English, it will be queen and king in Arabic. So this was a bit of a problem. So and as you'll see, might account for some of the results, or is one of the reasons that we might have gotten some of the findings that we did. So that for the existing ones, half were the same as English, but half were not the same in Arabic. And in doing this study and looking at binomials in Arabic, it might just be the case that word order in binomials is just much freer in Arabic. So in English, where we have something like fish and chips and fish is almost completely unattested, salt and pepper, and then pepper and salt is completely almost unattested. In Arabic, these phrases can have a preferred word order, but the less preferred one is often exists more. So you do see occurrence of it. And also we see that the preference is sometimes reversed. We also rewrote the stories so that they would encompass the most frequent 4,000 word families. So these would be sure to be known to the participants. The passages were a little bit shorter. And now, in order to get enough item power, we for the novel items, we, instead of having repetition 1, 2, 3, 4, 5, we just had 2 repetition levels. So they occurred twice and then were reversed, or they occurred 4 times and then were reversed. And the existing ones, like in the previous story, occurred once and then they were reversed. So time and money occurred once and then it was reversed later in the story. So to give us enough item power or more item power in this in the higher levels of occurrence, so in the 4 occurrence category, we just did 10 and 10. And again, if we had 10 items at 1, 10 at 2, 10 at 3, 10 at 4, 10 at 5, you just would have had passages that were just full of binomials, and it would just become ridiculous to read. So we decided to just do 2 and 4, and to have 10 at each level so that we would hopefully have sufficient item power. So if we look at this figure, if we look at the existing binomials, so this on the left-hand side, so this is the time and money and the money and time, we see that there's no difference between the sequence and its reverse form. So it's very much like the first study that we saw with the less proficient speakers. When we looked at proficiency, that didn't seem to matter or play a role in this, so it doesn't seem to be about proficiency, and it's probably because of the properties of the Arabic. So some of the items were actually had the reverse preference in Arabic, and this is something that we're considering in a follow-up study that we're doing. But when we see for the novel binomials, we get the nice processing advantage for the novel ones over their reverse form. So wires and pipes is significantly faster than pipes and wires. And if we see, if we look across the repetitions, and if we look at the first and the last for the 2 repetition category, the first is, there's just 2, so you just have the first and the last. But if we look at the 4 repetitions and the first repetition versus the last repetition, we see that that we get faster as we go. But if we look at the green bar, and again, now on the next slide, I'm going to show a bit of a caricature of the 2 sets of results. So the top is what we saw with the first study, and the bottom is what we see in the second study. And so the green bar seems to be just getting faster. So in the first study, we saw that there's a penalty to the reverse form to pipes and wires. So we are getting faster at the sequence, but the reverse form is slow. For the L2 speakers, it seems like the reverse form is just being treated as another occurrence of the sequence. So it actually has a significant speed up relative to the previous occurrences. So it seems that the words are becoming associated in memory for the L2 speakers. So just like we saw for the L1 speakers, they're associating these two words in memory, but the preferred word order is not recorded in memory. So for them, pipes and wires is just being treated as another occurrence of the phrase wires and pipes. So the question is, would this be true for other L1s? So is it just something about Arabic that these binomials have more flexible word order? Is it is it something that's more Arabic specific, that they don't have these big frequency differences between a forward and a reverse form? So we need to test this in other L1s to answer that. But the other thing is, the other hypothesis is that it just could take more occurrences for people to, for second language speakers to pick up on a preferred word order. So we would have to look at 8, 9, 10 occurrences in order to see this cost of the reversal. So is it Arabic specific that we don't see this cost of the reversal? And or is it something about L2 speakers simply need more input in order to pick up this word order preference? So they can associate the words in mind, but in order to know that there's a preferred word order and to treat that as privileged in terms of their processing, they would need more input. So that's the question. So some final thoughts. Hopefully I demonstrated that formulaic language is an important component of language, so it's very pervasive, and therefore it's important to our linguistic competence, both in the L1 and the L2. Eye tracking gives us a really great means of exploring formulaic language processing, formulaic language acquisition, and we can do it in fairly natural contexts. So we can look at it while people are just reading these natural stories. So they're not being told there's anything about formulaic language, they just read a story as they normally would, and we can see if a processing advantage emerges. We generally see a processing advantage for formulaic language in the L1 and sometimes in the L2. As I said before, we might not be seeing it in the L2 because we don't always account for an L2 speaker's input when we know what it is, or because we know what they've had for input, or we give them the input in the experiment. Then we generally do see this advantage emerge. And it appears that we can start to see a formulaic advantage in as little as 4 to 5 occurrences in terms of both the first and second language speakers. The first language speakers are not only attuned to the co-occurrence of words in language, but also the order that they appear in. The L2 speakers, we don't see evidence of this. And as I just suggested, there might be a couple of reasons for this. It might be about Arabic, or it might just be that second language speakers need more repetitions in order for them to become attuned to the ordering of the components. And I just need to acknowledge all the wonderful people I've had the pleasure to work with and that I've mentioned in this talk, and that all this work wouldn't have happened with them. And then to thank you to use a formulaic expression. So thanks a bunch.